In this video, I'm going to present about ocean tides. So ocean tides are rise and fall of seawater caused by gravitational forces of the sun and the moon and the rotation of the earth. So here two types of water levels are there: high tide water and low tide water. So high tide water occurs, suppose this is the coastal region. This is the coastal region. The water level, the water moves towards the coastal region, and because of that, water level increases near the coast. So that is called tide, and this water level is known as high tide water. Whereas if the water level is moving towards the sea it is moving, and the water level will fall, and that is called ebb, and that resultant water level is known as low tide water. So difference between high tide water and high tide water and low tide water, so which is called as tidal range. So in this we can see that this is the spring tide, this is the high tide level, and this is the low tide level. So the difference between these two is known as a range of spring tide. So here we can see the flood tide, so which is moving towards the coast because of the water level is increasing, which is also known as high tide. Whereas ebb tide, here the water is moving towards the sea and the water level is decreasing, and this is called as a low tide. And the difference between this high tide and low tide is known as tidal range. Factors affecting tides are gravitational forces of the sun and moon, centrifugal force of the earth due to its spin and its revolution, and from this barycenter of the earth, and the moon's path during revolution, which is perigee and apogee. So perigee, the position of the moon, suppose this is the earth and the moon is revolving around the earth like this. Perigee, suppose this position is the perigee, this is the nearest position towards the earth, so here the gravitational force will be much more, and whereas this is the furthest position, which is apogee, so here the gravitational force is much less. So when during perigee period, the gravitational force is 32 to 48% higher than the apogee position. And earth's revolution and changing distances with the sun, so like equinox, so suppose this is the sun, here earth is revolving around the sun, so here in this position, this is the equinox position, so here the distance between the sun is less, whereas in this position, so this position is called perihelion, whereas this position is called aphelion, so here the distance is much more. So in this position the gravitational force is more, whereas in this aphelion position the gravitational force is less towards the sun. The influence of the gravitational force is much less on the earth. So various lunar phases of the moon, so that we can see later. And gravitational forces, so gravitational force is related to the mass of the object and the distance between these two objects. Suppose earth mass of the moon is just one fourth of the earth mass is the moon's mass, though mass is less but it is very near to the earth, so the gravitational force is much more than the sun, because sun is the object, the sun is mass of the sun is more, but the distance between these two, this distance between the earth and sun is much more. So that's why the moon's gravitational force acts major acts or influences the tides much more than the sun's gravitational force. So here lunar phases, let's see these lunar phases. Here the sun is there, and here this is the earth and this is the moon. So this is the new moon period. So here between the sun and earth the moon lies, whereas in full moon period between the moon and sun the earth lies. So that's the difference between full moon and new moon. So here we can see the new moon period, the sun rays are falling on the moon surface, but this side which doesn't receive the sun rays is visible to the earth. The person who is standing on the earth can only see this darkest part, the darkest part of the moon, so it is not visible to us because it is not illuminated part, it is not visible to us. Whereas here this illuminated part, so this is called waxing crescent. From new moon the size of the moon increases, which means the illuminated part can slowly increases, so it's less than half of the part is illuminated part is visible to a person who is standing on the earth. Here it's first quarter, then here this is waxing gibbous, here more than half of the part illuminated part is visible to us, and full moon, half of the whole moon is visible. The whole illuminated part is visible to us, which is also known as full moon day. Here the illuminated after full moon, the illuminated part decreases slowly, that is waning period. Here waning gibbous, the more than half of the part is visible, and here the last quarter, and it's a crescent, so only this part is visible to us. So that's how the lunar phases, varying lunar phases occurs. There are two kinds of months we calculate when we can study about moon and its revolution. So there are two types of month. One is sidereal month. One another one is synodic month. So sidereal month, which is around 27.3 days. So this is it is a time taken to make one complete orbit around the earth with respect to a fixed star, which is 27.3 days, whereas synodic month it takes around 29.53 days. So it is the time taken to revolve around the earth. So actually, if suppose new moon phase, then again it comes to the same usual phase of new moon phase. Otherwise, take it as a full moon phase, and again it comes to the full moon phase. So this is averagely it is taken. This varies annually, but on average it is taken as 29.53 days. So rotation and revolution. During rotation and revolution, this the distance between the moon and the sun, so that varies. Suppose in perigee period, as I said, perigee period the distance is less, whereas in apogee period the distance is more. So here in this moon, this is 3,56,000 during perigee, whereas apogee it is more than 4 lakh kilometers. So because of that, the gravitational influence gravitational force influence on the earth also decreases during apogee period. Same it happens in the aphelion period also and perihelion period also. Suppose how the tide occurs. Here the moon, the gravitational force is, here the moon's gravitational force is falling on the earth, and this gravitational force is because since water is in a liquid state, easily it is this gravitational force can create a bulge on this water, oceanic bulge it creates. At the same time, because earth is rotating and it's revolving around the sun, so it has some reactionary force or rotational forces happening here. Because of that, this side, because of the centrifugal force, this side also a bulge is created. Though moon's gravitational force is much more on this side, but here it is less, it affects very less, but the rotational force is stronger than the gravity in this region. Because of that, in this region also a bulge is created. So here also high tides occur, and in this region also high tides occurs. So that's how the tides are originated. And the two sides of the earth, there are moon facing side and opposite side. As I said, moon facing side has less distance and gravitational pull is maximum, water is pulled, high tides are occurring. At the same time, opposite side also more distance is there and gravitational pull is minimum, but reactionary force or centrifugal force, because of this high tides occurs. So both the side, moon facing side also, opposite facing side also, at the same time tides occurs. Those high tides are high tides. Phases of tide. So flow, high tide, ebb and low tide. Flow is an incoming phase when the water rises again. So because here in the flow, flood tide occurs, which means here water level is increasing because it's moving towards the coast. Water level is increasing. Because of that, high water level occurs, and this tide is called high tide. Whereas this is ebb is outgoing phase, and the tide is drained. The water is drained, and towards the shore, from the shore it moves. The water moves towards the sea, and that resulting low water level is known as low tide. Time of tides. Earth rotation takes 24 hours, and on average every place experiences tides twice daily, but each day tide is delayed by 26 minutes. So let's see why is the delay. And the moon rotates west to east and revolves around the earth. Each earth also rotates west to east, so the tide center shifts westward. It takes another 52 minutes to come under the moon. A particular tide center, it takes, so to come under a particular tide center, the earth takes around 24 hours 52 minutes to come under the moon. After the tide, ebb occurs after 6 hours 13 minutes. So let's see why it happens. At point P, suppose the earth is rotating, say from point to P, it is rotating and again it is reaching point P, so which is around 24 hours. So we know that it takes around 24 hours. By the time, since the rotatory force of the moon is very less, and the moon is revolving around the earth like this. So by the time the moon, which was there in the, when the earth started rotating from P, by the time the moon was there in the position point K. So when it finished one round, one rotation, so it is moving to point L. So this distance, PF distance, the earth has to rotate further from point P to, it has to reach point F to come under the influence of the moon's gravitational force. So that's why this PF distance takes 52 minutes, because it is 255th part of the moon's orbit. The PF distance is 255th part of the moon's orbit in 24 hours. So the moon revolves around 250, moon moves from K to L. So this is the 255th part of the moon's orbit. So when we calculate that, we get 52 minutes. When we calculate that, we get 52 minutes. So this is divided by this is divided again, and so that is we get 26 minutes. So that's how the tide center is shift every time, after every rotation the tide center takes 52 minutes additionally to come under the influence of the moon. So that's why each tide takes 12 hours 26 minutes to reoccur. Tides and positions. So here in this we can see sun is there, new moon, here moon is there and earth is there. So here these three celestial objects are in the same line. So this is called syzygy. And here in full moon day also, the sun, earth and moon, they are in the same line. So that is also called as syzygy only. Whereas in the other periods, suppose in the first quarter or first quarter or third quarter, if you see, these objects will be perpendicular to each other. This object will be perpendicular, which is in right angle. So that's why when it is in same line, the gravitational force is much more, so the high tides occurs. But when it is in perpendicular, when these celestial objects in perpendicular position in relation to earth, so here this gravitational force acts like this, this gravitational force acts like this, so this weakens the tides. So here the low tides occurs, or Neap tides we call it as. When these are in the same lines in the syzygy, high tides occurs, where in the right angle position or perpendicular to earth position, then the low tides occurs. So let's see what is syzygy and other positions. So in same line position, the gravitational forces work together, high tides are formed. These positions are called syzygy. These positions, they are called conjunction and opposition. Conjunction occurs on new moon day, so opposition occurs on full moon day. So during conjunction what happens is the sun and the moon are in one side. Suppose the sun is here, this is the sun and the moon and the earth. So sun and moon are in one side, the earth is in this side, so which is a new moon day. Because sun rays falls like this, only this part is illuminated, we can't see the illuminated part, so that's why new moon day. And opposition, here the sun is there, earth is there, here moon is there. So this illuminated, the full illuminated part can be visible, so that's a full moon day, which is also called as opposition. And quadrature, so the sun, earth and the moon are in the right angle position with respect to earth. So this is the earth, this is the sun and this is the moon. So like this it will be in the right angle position, or it will be perpendicular to each other. And types of tides. Intensity of tide producing forces vary temporally and spatially. Some of the important tides are spring tides, neap tides, tropical and equatorial tides, Apogean and Perigean tides. So we know that moon completes one revolution with respect to the visual phase. So around 29, let us take it as 29.53 days, which is synodic month. So spring tides, neap tides occurs in a particular month itself, because full moon day, new moon day both occurs, and these occurs also. Tropical in equatorial tides with respect to tropics and equatorial tides, so it also completes this. And Apogean and Perigean tides also is, because in one revolution occurs in the one month itself, so these also occurs in a particular month. But daily and semi-diurnal changes, these are daily changes. But equinoctial spring tides, this is with respect to the sun, because in the period of equinox, which is also called as perihelion period, it occurs. So it's a equinoctial period, so this occurs annually, but these things occurs as monthly phenomena. These are daily phenomena. And spring tides, very high tides occurs during Sisigi, twice in a month occurs during new moon day and full moon day. So we know that in full moon day and new moon day, these spring tides occurs. They are very high tides caused by combined gravitational forces of the sun and moon. Height of these tides is 20% more than the normal tide. And neap tides, so we know that it occurs when it is in right angle, or which is or in perpendicular position to the earth. These celestial bodies are perpendicular to the earth, so this position is also called quadrature position, and it occurs on 7th or 8th fortnight of every month. Tide producing forces work in opposite direction, because this is working like this, this is working like this, so these are working in opposite direction. And so that low tide is caused, and the height of the tide is 20% lower than the normal tides. Tropical and equatorial tides, in relation to the sun, earth position is classified into equator. We know that, suppose this is the equator, these are the tropics. So this is the tropic of Cancer, this is called as tropic of Capricorn. So with sun's position, how we calculate this as a equator, tropic of Cancer, tropic of Capricorn, like that. Also with sun's position, this is classified when the moon's light is falling vertically on the tropic of Cancer or tropic of Capricorn. So here these tropical tides occurs when it falls on equator vertically. When this moonlight is falling vertically on equator, the equatorial tides occurs. So we know that synodic month, which is 29.5 days. Similarly, moon also sun revolution takes 365 days, like that. Moon rotation with respect to visible phase, it takes 29.5 days, which is also known as synodic month. If there is maximum declination of moon to north of equator, moon rays falls vertically on tide centers near the tropic of Cancer, spring tides occurs. Similarly, when it falls on tropic of Capricorn, then also spring tides occurs. But when these tides are called tropical tides, because it's falling on the tropics. But successive high and low water occurring along the tropic of Cancer and Capricorn are also called unequal heights. But at the same time, equatorial tides, what happens, let's see. Before that, these tides and ebbs are of higher and lower heights than the normal tides and ebbs. So these are very tall, and the water level is high, or very water level is high during the tide period, and during ebb period the water level is very low. So these tides recur every month twice. And equatorial tides, there is no diurnal inequality of tides in terms of heights of 2 neap tides and 2 spring tides when the moon is vertical on the equator. So here there is no inequality in the equator. Apogean and Perigean tides, so the nearest position of the moon with earth. So we know that is perigee, the farthest position. If it is perigee, here the force is more, so because of the gravitational force, high tides occurs. But farthest position, the tidal force is minimum, so low tides occurs. When the spring tide and Perigean tide occurs, at the same time, the resultant tide will be abnormal. When the neap tide and Apogean tide occurs at the same time, the water level becomes significantly low. So Perigean, the gravitational force is more. At the same time, spring tide also, it's a high tide, so here abnormal tide occurs. But in Apogean, gravitational force is less, neap tide itself is a low tide, and because of that, water level becomes significantly low. Diurnal and semi-diurnal tides, so here these are daily tides, and the tides are recurring at the interval of 24 hours 52 minutes daily, are called diurnal tides, so or daily tides. The tides recurring at the interval of 12 hours 26 minutes are called semi-diurnal tides. So this is for one day, and this is for half a day 12 hours 26 minutes. This is 24 hours 52 minutes, because it takes additionally 52 minutes to come under the moon's influence again. Equinoctial spring tides, as I said, this occurs in the perihelion position. The tides recurring at the interval of 6 months due to the revolution of the earth around the sun and sun's varying declinations are called equinoctial tides. So in this image we can see this is this is sun, this is earth. So the distance between the earth and sun here, it is less. This is called equinox, which occurs in the month of March and September. So during this period, the tides which is occurring, so here it takes 6 months. So this is 6 months, and to occur March again 6 months, to occur in September again it takes 6 months. So these tides are called equinoctial tides. Tidal bores. So tidal bores are crest or a wave, and it is a steep wall like moving upstreams from their mouth when the tidal waves enter the low-lying rivers. The conducive conditions for occurrence of tidal bores are narrow, low-lying coastal river with gentle channel gradient, a bay with narrow opening, tidal range more than 5 meter. An example, the Chiantang River of China, 8 meter height tidal bore occurs in this region. So let's see how the tidal bore occurs. So here steep wall like water. So this is a narrow stream here. So narrow mouth of the river. So here the water moves towards the river. So this sea water moves because it's a low lying region. It moves like this, which is also called tidal bore. And here tidal currents. So these are generated by tides due to upward and downward movement of sea level in the open and near shore regions. So these are many types are there. First one is flood currents. Here the coastward movement of the tides and piling of water. So here suppose say this is the coast. Here the water is moving like this, and the water is piling here. These are called flood currents, coastward movement of tides. Whereas ebb currents, here ebb currents, they move towards the sea like this, and from the coastal region they are called ebb currents. And the rotary currents, they occurs in the open ocean. So they occur in the open oceans, and the velocity is 1 kilometer per hour. In the northern hemisphere they turn anti-clockwise. In the northern hemisphere they turn anti-clockwise direction. In the southern hemisphere they turn in clockwise direction. Reversing currents, when the rotary currents come towards the coast, when they reaches the near to the shore, these reversing currents occurs. The velocity also increases because the friction near the coast increases. Because of that, velocity also increases. That velocity will become 44 km per hour. So tidal currents are very important in power generation. So these are all